Hey there guys, we're ready for part C of the AP Cell Transport Lab about osmosis and diffusion. So we're about to embark on part C using dialysis tubing. I hope you're excited. You should have already on your data table recorded your hypothesis. What I was looking for in this section was for you to hypothesize in each of the scenarios whether water was going to move in the bag, out of the bag, but also include kind of like why, but don't use first person. I'd like you to use words like, this side or this solution is hypertonic in comparison to the other side, meaning beaker versus cell, and then predict based on the solute concentration. So this is going to take you a lot of room to do that. So we've got 5 setups. Okay, setup A, the cell is our dialysis tubing. That's what the cell is. And then the beaker is going to be the cups that we have labeled here. So we're using these plastic cups, A, B, C, D, and E. And I've already placed the solutions in those. So A is distilled water, B is distilled water, C is distilled water, D we have NaCl in our cup, and then E is also distilled water. So 4 out of the 5 have distilled water. D is the special scenario. That's the one that you can see we're putting salt in the beaker, and these are really plastic cups. Okay, our cells, we're going to put glucose in the first dialysis bag, NaCl in the second one, sucrose, then we're going to put glucose, and obviously E is our control that we hope that we don't have a change in mass, but we never know because sometimes things happen, right? Okay, so this is what it looks like when you put dialysis tubing in distilled water. I've already washed my hands, by the way, so my hands are clean. And this is dialysis tubing. When you soak it, it's really kind of pliable. So what you have to do is like this with the hand. You can see like this. You have to kind of like move it, get an opening in it. Once we have an opening, then we know that we can put some solutions in there. But first what I have to do is tie a knot in one end. So I'm going to do that. Okay, so I have my knot in one end. You can see it down there at the bottom. I'm holding the top end with my fingers, and this is gonna be our setup A. So we're ready to take 10 milliliters of glucose. So these are my solutions in the cup. You can see how I have them prepared. So we're gonna use a pipette and take 10 milliliters of glucose. I have my little mini graduated cylinder so that I can have some accurate measurements. So I'm gonna use that plastic pipette and transfer 10 mils of glucose to the graduated cylinder. So there's my 10 mils. I'm ready now to transfer that into the dialysis bag. So I'm just gonna pour it from the graduated cylinder into the bag. Okay, so here is the little bag, dialysis bag with the 10 milliliters of glucose. I need to knot the other end so that I have a bag, but I'm gonna leave some room for expansion. I don't wanna tie it really tight. I want to make sure I have some room in there in case water is going to enter the bag. Okay, so here's my first bag. I've got my 10 mils of glucose inside my dialysis tubing. I'm going to keep it moist. I have a spray bottle of distilled water, so I'm going to spray that and keep it moist while I prepare the other ones, and then I'll go ahead and mask them all before we put them in the cups. Okay, so we have all of our bags filled up, ready to go. Look how beautiful they are. There's A, B, C, D, and E. We don't want them to dry out, so I've been spraying them, kind of holding them up over the sink, keeping them moist. So now we're ready to mask them before we put them into our beaker solutions. So we're going to turn the scale on. Here we go. We've got grams. Everything's tared. So bag A, our first little guy, let's put him in here. And we're going to call that 10.93 grams. So we're going to record that right here. 10.93 grams. All right, that's bag A. Okay, we're ready for bag B. 11.80. 11.80 grams. Okay, ready for bag C. We'll call that 12.89. Okay, bag D. Wow, that one's huge. 15.11 grams. Remember, we're doing percent change in mass So it really doesn't matter that that one was so large to start off with. I mean, ideally we would like to make sure that it's 10 milliliters of each solution, but because we're doing percent change in mass, all the different dialysis bags could be different lengths. You can kind of tell how long that one is. So I may have cut my dialysis tubing a little long, so that's quite all right. Okay, here's bag E, 12.67. 12.67 grams. Okay, so those are all of our initial masses for our setups. Now what we're gonna do is take all of them and drop them in the cups. So there's E, D, C, B, and A. We're gonna make sure they're submerged. Okay, so we're gonna stick them down a little bit. And then we're gonna start our timer. Now the lab directions say 30 minutes, but due to the lack of time in class today, we're actually cutting it down to 20 minutes so that everybody has the same snapshot. So we're gonna leave them in here for 20 minutes and then we'll come back and see what happens. Okay, so our bags are done. We have completed the 20-minute snapshot. So I have them out here, you can tell, on the paper towels. So I have already masked them all. So these are your post masses. You can see right here, go ahead and copy down. Bag A, looks like we have an increase, went from 10.93 to 12.20. Bag B went from 11.80 to 12.30. Bag C, 12.89 to 15.18. Bag D, 15.11 to 15.95. And then bag E slightly changed, 12.67 to 12.73 grams. So what you need to do now is calculate that percent change in mass, which is you take the final 12.73, like in this case, minus the initial, okay, then divided by the initial, multiplied by 100, and then you'll get that percent change in mass. So the formula is in your protocol, but go ahead and calculate that if you don't mind. You'll need to do that for that part of the lab. So that's part C. You saw how that worked, kind of cool, right? Okay, now for the conclusion for part B of your lab from yesterday. These are your potatoes from yesterday. Look at that. Don't they look pretty in there? So we want to take the mass, take these out. So I have it set up where I've got some paper towels. I have a plastic spoon, and we're going to start with a red cup and try to make the least amount of mess as possible because these are going to be grody. Okay, so I'm going to put on the paper towel, kind of let some of the water drain off. Our scale is tared, so we're ready for you to record the mass for the red cup. So we're going to plop these on. There you go, 6.39 grams. So we're going to record that right here, 6.39. Okay, now we're ready to do the next color. Make sure our scale is tared, yep. Ready for orange. Take these out, whoa. Okay, take the orange color. And we are at 11.82. 11.82. Okay, now we're ready for the yellow. Let's get rid of those. Ew, look what those look like. Nasty. They're like brown. Okay, let's make sure our scale's tared. I can see that there's a little bit of liquid on there. Okay, so the yellow solution, 5.32. 5.32 grams. Okay, we're gonna come back over for the green. Let's get rid of these. Anybody want any sugary potatoes? Okay, we'll take these green ones out. Pat them dry a little bit. Okay, so green is, let's go with, what do you think? All right, stop. 9.66. 9.66 grams. Okay, blue and purple is all we have left. Two more. blue. Drop those. Our scale is tiered, so we're ready. Okay, blue we have 5.94. And then last but not least, ready for the purple. Put these over here. We've got 7.22. 7.22 grams. Okay, so you're going to calculate for these the percent change in mass. Once again, you want to take a final minus the initial divided by the initial and then multiply by 100 and you'll get your percent change in mass. If they do come out negative, as you can tell, like this first one, these lost mass, we want to keep the negative sign. So we know that this first one's going to have a negative because our potatoes went from 8 to 6. These, look at the next one, 11 to 11.82, that gained, so that's going to be a positive number. We know that's going to be a positive. This one's 7.89 to 5, so we're going to have a negative number there. From 797 to 966, that gained, so we know we're going to have a positive. And then from 8 to 5, we've got a negative, and then 8 to 7, we've got a negative. So we've got quite a few here that are negative, so we're going to see like how much, what was the exact percent change in mass. Okay, that concludes our AP lab.